Hi guys, in this video we're going to go over few examples of differentiation where we're going to be using power rule to differentiate. So let's get started. Example 1, we have y equal to 5x plus 5. We need to expand this bracket before we can differentiate. So we're going to have y equal to, by the time we expand this bracket, this 5 is multiplying everything in the bracket. So if we expand the bracket, we're going to have 5 multiplied by s. We have 5x, 5 multiplied by 5, we have plus 10. Then we can differentiate. The y dx, y, if you differentiate y, you're going to have the y over dx equal to 5x. Remember, we said we're going to drop the power because this x, we're having 1 here, invisible 1, minus 1 is going to 1 minus 1 is 0. So n to the power of 0 is 1. So we're going to have 5. And remember, in differentiation, a constant is always 0. So here is going to be 0 plus what? 0. So the y, or the y dx is equal to what? 5. That's all for this. So example 2, we have y to be equal to 4 open bracket x squared minus 3. We're still going to do the same thing, expand before we differentiate. Y equal to 4 multiplied by x squared, we have 4 x squared, then 4 multiplied by 3, we have minus what? 12. Yeah, so now we can differentiate. The y is the y over dx. That's if you differentiate y, you're going to have the y dx equal to 4. Remember, you're going to drop the power. So if you multiply this to 2 multiplied by 4, you're going to have 8x, then minus 1 from this 2, you're going to have x. Then remember, constant is always 0. So our dy over dx is now equal to what? 8x. That's all for this question. So let's go over example 3. Example 3, where we have y equal to s cube open bracket s square minus 3x plus 1. We're still going to what? Expand the bracket. This s cube outside is going to make everything inside the bracket before we can differentiate. Our y is going to be s to the power of s cube multiplied by s squared is going to give us x to the 5th power minus s cube multiplied by 3x is going to give us 3x to the 4th power, then plus s cube multiplied by 1, still s cube. So now we can differentiate. Our y is the y over the x equal to, by the time you draw the power, it's going to be 5x minus 1, going to be 4 minus 4 multiplied by 3, going to be 12x. If you minus 1 from the power, it's going to be 3 plus 3. If you drop the power, 3x minus 1 from the power, going to be what? 2. So that's all for this example 3 as well. So let's go to example 4. We have 2x minus 7 all squared. Remember, in this case now, we are going to expand the brackets before we can differentiate. So let's get started. Y equals to 2x minus 7, 2x minus 7. Then we can what? FOIL. That is, we're going to what? FOIL. This 2x multiply this 2x, so we're going to give us 4s square. This 2x multiplied by 7 is going to give us minus 14x, because 7 times 2 is 14. Then this 7 multiplied by this is going to give us minus 14x as well. Then 7 times 7 is going to give us positive 49. Then now we can differentiate. Our dy over dx is equal to what? We drop the power, we're going to have 8x minus, before we differentiate, we're having the same, we're supposed to rearrange before we differentiate. So we have y equal to what? 4s square minus 14 is going to give us minus 28x, then plus 49. Then now we can differentiate. Our y is going to be dy over the x equal to, now we're going to drop the power, so this power is going to multiply this 4, so we have 8, then minus 1 from the power, which is 1. Anything raised to the power of 1 is that number, so we have x minus, now we have 1 here. By the time we minus 1, it's going to be 0, and anything raised to the power of 0 is 1, so we're left with what? 28. And constant are always what? 0. So our final answer is going to be dy over ds equal to 8x minus 28. That's our final answer. Let's solve the last one. And example 5, we have x minus 2, 3x plus 5. So our y equal to this is still going to expand the bracket. We're going to FOIL. So this x multiplied by 3x, we have what? 3x square. X multiplied by 5, we have plus 5x. Then minus 2 multiplied by 3x, we have minus 6x. Then minus 2 plus this 5, we still have minus what? Minus 10. So y equal to 3s square minus 5x minus 6x. Just like saying 5 minus 1 is going to give us negative x minus 10. Now we can differentiate. The y over the x is equal to, if we drop the power, we have 6x, then minus 1, because this x is just like saying x raised to the power of 1. Then if you minus 1, if you drop the power, we have 1x, 1 minus 1, if you minus 1 from the power. So anything multiplied by x, we still have 1 multiplied by x, we still have x, then 1 minus 1, we have 0, and anything raised to the power of 0 is what? 1. That's why we're having 1 here, and a constant is always 0. Then minus what? 0, minus 0, sorry. So our dy dx is going to be 6x minus 1. So let's solve one last example. Let's solve this example. Example 6. Let me solve it here. Example 6. We're given x to the power of 7 minus x to the power of 5 all over 4x y equal to this. So here now, before you differentiate, what? We clear the fraction. Where we're going to be having y equal to x to the power of 7. If this one is coming to the top, it's going to the top, we're going to have minus 4, then minus 5 is to minus 5, minus x to the power of 5, minus what? This 4 is going up from your indices. Then we're going to have y equal to x raised to the power of what? 3. 7 minus 4 is 3, minus 4 minus 5 minus 4, we have x, just x. So now we can differentiate. Our y is going to be dy over what? The x equal to 3x squared. If you drop the power and minus 1 from the power, we're going to have 3x squared minus 1, just like the way I explained initially. So that's the final answer. Thanks for watching. Please subscribe, share, and like.